picture this. You're holding a standard everyday pencil in one hand, and in your other hand, you are holding an industrial drill bit.
Right, the kind that can just tear through solid rock.
Exactly. And, on the surface, these two objects seem like they exist in completely different universes. I mean, one is so soft and fragile that it leaves this dark streak when you lightly drag it across a piece of paper.
And the other is literally the hardest naturally occurring substance on Earth.
Right. But if you zoom in close enough, like way past the surface, down to the microscopic atomic level, you actually find the exact same raw ingredient in both of your hands. Pure carbon.
Which is, frankly, kind of mind-blowing when you really stop and think about it.
It really is.
Yeah.
Okay, let's unpack this. How does the exact same chemical building block create both the softest pencil lead and, well, the most indestructible diamond?
That is the big question.
And more importantly, what can that extreme physical paradox teach us about human nature, about how we structure our teams, and believe it or not, about the evolution of the human soul?
Yeah, that is the exact journey we are taking today. We are looking at this highly unique essay from 2012 by an author named Feng. It's titled The Enlightenment from the Structure of Graphite and Diamond.
Catchy title.
Right. But what's fascinating here is that the source material starts off as this rigorous, hard science chemistry lesson. I mean, it breaks down the precise physical statistics of carbon, but then
It takes a huge turn.
it really does. The author makes this wild, thought-provoking leap. The text takes those chemical properties and uses them as a strict, literal blueprint for philosophy, for team management, and ultimately some very specific metaphysical claims about spiritual enlightenment.
Wow.
Yeah. So we are going to impartially explore this author's worldview today, just looking at how they connect molecular bonds to the human experience.
I love that. And to the listener, I want you to think about your own life for a second. Imagine having all the raw talent, all the right ingredients, like all the potential in the world, but still falling completely short simply because of how those ingredients are arranged.
Because the arrangement really is the secret sauce here.
Exactly. If this deep dive reveals anything, it's that the raw material isn't where the magic happens. The arrangement is everything.
Right. But to truly grasp the massive philosophical leaps the author makes later in the text, we first have to ground ourselves in the physical reality of these two materials.
We have to understand the science first.
Exactly. We need to understand the tale of two carbons. So let's start with graphite, the material inside that pencil you mentioned.
The soft stuff. The material that practically crumbles when you touch it.
Right. On a macroscopic level, it is incredibly soft. The text notes it has a hardness level of just 1.
Which is basically nothing.
Yeah, but structurally, it's actually a marvel. Graphite is technically a transition type between atomic, metallic, and molecular crystals.
Okay, what does that actually mean for the atoms themselves?
Well, its carbon atoms use a specific bonding structure called sp2 hybridization. And what that means, practically speaking, is that every single carbon atom connects to 3 other carbon atoms.
Just 3.
Just 3. And together, they form these sprawling, flat hexagonal rings.
So it looks kind of like a microscopic honeycomb, right?
Yes, exactly like a honeycomb. But it's entirely two-dimensional. It's just a flat sheet.
Just one layer.
Well, it's a series of flat sheets stacked on top of one another. And the physical statistics of this honeycomb structure are just full of paradoxes. The text points out that graphite has a density of 2.25 grams per cubic centimeter.
Okay.
It's gray-black, opaque, and it actually feels incredibly slippery to the touch.
Oh, right, because those flat layers are just sliding around.
Exactly. But here is the major paradox. Structurally, it's weak enough to snap between your fingers, right?
Yeah.
Yet chemically, it is nearly invincible. It is highly stable. It resists corrosion, strong acids, alkalis. And if you want to melt it, you have to subject it to 3,652 degrees Celsius.
Wait, really? That is staggering. A hardness of 1, but it takes thousands of degrees to melt.
Yes, and the text says if you want it to actually burn, like catch fire, you have to hit it with nearly 700 degrees Celsius in an environment of pure oxygen.
Just to turn it into carbon dioxide. That's wild.
It is. And because of that extreme thermal and chemical stability, we use graphite in incredibly intense industrial applications.
All that.
Things like anti-wear agents, industrial lubricants, high-temperature crucibles, and dry batteries. High-purity graphite is even used as a neutron moderator in atomic reactor.
In nuclear reactors. That soft pencil stuff.
The exact same stuff. But there's one specific detail about graphite's structure, a quirk in its chemistry that becomes the absolute foundation for the author's later metaphors.
Okay, I'm intrigued. What is it?
It's the free electron factor.
Okay, I want to make sure I understand this because it gets a bit dense in the source text. Carbon naturally has 4 available electrons it can use to bond with other atoms, right?
Correct. 4 potential bonding hands.
But in this sp2 honeycomb structure you just described, each carbon atom only connects to 3 neighbors.
Right.
That means every single atom has 1 electron left over, just hanging out with nothing to hold on to.
You've hit the nail on the head. Those leftover p-orbital electrons from each atom overlap with one another. They form what chemists call delocalized pi bonds.
Whoa, hold on. Delocalized pi bonds. You just lost me there. Are you basically saying these electrons are free-floating nomads that don't belong to any specific atom anymore?
That is a perfect way to visualize it, honestly. Instead of being locked into a rigid partnership, those leftover electrons create this shared, drifting ocean of energy.
Right, wow.
Yeah, they roam freely between the flat, stacked layers of the honeycomb, and those free-roaming electrons are what give graphite its metallic gray-black luster.
That makes sense.
And crucially, because those electrons are free to move, they're able to carry energy. They are the sole reason graphite conducts heat and electricity so efficiently.
Okay, that is fascinating. Now let's contrast that entire system with diamond, because we are still looking at pure carbon here. Not a single ingredient has been added or removed.
Right, it's 100% carbon.
But the architectural blueprint is totally different.
Completely different. Diamond is a typical atomic crystal, and it acts essentially as one giant continuous molecule.
So no separate flat sheets.
No sheets at all. Instead of that flat sp2 honeycomb, diamond uses sp3 hybridization. Every single carbon atom is tightly, permanently bound to 4 other carbon atoms.
Okay, so it uses all 4 hands.
Exactly. And they form these rigid, 3-dimensional shapes called tetrahedrons.
So there are no leftover hands. Every single electron is locked into a bond.
0 leftovers.
There are no free-floating nomads, and there are no flat layers. It is just a perfectly locked 3D grid.
Exactly. And the statistics totally reflect that structural rigidity. Diamond has a higher density, sitting between 3.15 and 3.53 grams per cubic centimeter.
Right.
It has a hardness of 10, the absolute maximum on the scale.
Unbreakable.
Pretty much. It's generally colorless and transparent, though the text mentions that random impurities can turn it blue, yellow, red, or even black.
Which makes for great jewelry.
Of course. But structurally, it doesn't conduct electricity at all. Under UV light, it fluoresces a pale cyan blue, and we use it for the most punishing tasks imaginable.
Right. Grinding, deep earth drilling, cutting through metal, wire drawing.
Yeah, and you can even manufacture it artificially out of graphite if you apply immense high heat, crushing pressure, and a catalyst.
That is just incredible. But there was one detail in the text, however, that I found incredibly counterintuitive when you compare the two.
The melting point.
Yes. We just established that diamond is infinitely harder than graphite. But did you catch the melting point of diamond?
I did. The text lists the melting point of diamond at 3,550 degrees Celsius.
Which is actually slightly lower than graphite's melting point of 3,652 degrees.
Right.
You would naturally assume the harder, unbreakable material would be harder to melt, but it's not.
It's a brilliant little quirk of physical chemistry. It proves that mechanical hardness and thermal stability aren't the exact same thing.
Right. They measure different types of strength.
Exactly. The 3D grid of a diamond is structurally rigid, but the specific bond energies in those flat sheets of graphite actually require slightly more thermal energy to pull apart.
That's wild.
But the overarching point the author draws from these exhaustive profiles is undeniable. Structure dictates function.
Absolutely. So what does this all mean for us? If you're trying to visualize why, like a loosely stacked deck of playing cards,
I like that analogy.
within each individual card, which represents one flat layer of the honeycomb, the bonds are relatively strong. The card itself doesn't tear easily.
Right.
But between the cards, there's barely anything holding them together. You push the deck from the side, and the cards just effortlessly slide right off each other.
Right, there's no vertical strength.
Exactly. That is exactly why your pencil leaves a mark. You are literally sliding microscopic layers of carbon off the stack and leaving them behind on the paper.
That's such a clear way to picture it.
Diamond, on the other hand, is like a perfectly interlocked, 3-dimensional Lego fortress. You push on one side of it, and the entire structure pushes back at you all at once.
Because every piece is connected in every direction.
Exactly. The ingredients are exactly the same. The architecture changes the reality of the object entirely.
So we have this undeniable physical rule. The arrangement of the pieces matters far more than the pieces themselves.
Okay, but how does this connect to human nature?
Well, the author asks, does that rule stop at the boundaries of chemistry? What happens if you take that exact same logic and apply it to human beings? What if you apply it to a corporate boardroom?
Ah, okay.
This is the first of what the text frames as enlightenments. The author poses a profound question. If molecular arrangement dictates a material's physical strength and utility, does human arrangement dictate a team's power?
When you look at management theory, it actually makes a lot of sense. The essay argues that a team with poor arrangement, bad combinations of roles, unclear hierarchies, lack of cohesive structure,
Right.
is exactly like graphite.
It's loose. It's loose. Yeah, it's physically weak. The layers just slide off each other the second any real pressure is applied.
Right. The text explicitly states that this kind of setup has terrible management efficiency.
But a properly arranged team, where every single person is locked into a mutually supportive structure, that's a diamond. Powerful, unbreakable, and highly efficient.
It serves as a very compelling analogy for organizational behavior. It all boils down to how the atoms, meaning the individual people, are linked together.
Are you building a loose stack of cards, or are you building a tetrahedral fortress?
Exactly. But Shvefin doesn't stop at the surface level of an organizational chart. The second enlightenment goes much deeper, probing into the psychology and the internal beliefs of the individuals within that team.
Oh, this is where the author brings back that crucial concept of the free electrons.
Yes, the free electrons.
In the chemistry section, those were the leftover nomadic electrons just wandering between the layers of graphite.
Right, the ones carrying the energy. So, the author takes that physical reality and equates those free-roaming electrons to people within a group who hold differing beliefs. People who act independently, or people who just prefer doing their own thing.
Basically, the nonconformists.
Yeah. Schwiffing argues that this independence causes internal friction. It results in low cohesion, low efficiency, and a massive drain on the group's energy.
Because they aren't locked into the grid.
Exactly. The ideal team, according to the logic of this essay, is exactly like a diamond. Absolutely zero free electrons.
Everyone on the exact same page.
Right. Everyone is locked into the exact same belief system, moving in the exact same direction, making the group invincible.
And the text leaves no room for ambiguity on this point. It views differing viewpoints within an organizational structure as a fundamental source of weakness.
It's a very rigid view of teamwork.
It is. The logic is simple. A diamond has no free electrons, and a diamond is unbreakable. Therefore, a team without independent, diverging actors is an unbreakable team.
But here's where it gets really interesting, though. Because if we look strictly at the text, at the very science the author presented just a few paragraphs earlier,
There's a contradiction.
there is a massive, glaring contradiction. The essay explicitly stated that those exact same free electrons in graphite are the sole reason it can conduct electricity and heat.
Right.
That conductivity is exactly why graphite is vital for dry batteries, arc furnaces, and electrodes. Doesn't this mean the author's deeply negative framing of independent thought completely ignores the fact that those free electrons are exactly what gives a system its energy, its flow, and its spark?
If we connect this to the bigger picture, you have identified the fundamental tension of this entire metaphor.
Thank you. I thought I was crazy for noticing that.
Not at all. The author places supreme, unquestioned value on the rigid, invincible, unyielding structure of a diamond. And from a certain perspective, they are right.
Sure. If you're drilling rock.
Exactly. If your only goal is to cut through solid rock, you absolutely want a diamond. But if your goal is to generate a spark, to conduct power, to adapt, and to transfer energy from one place to another, you need graphite.
You desperately need those free electrons.
You do. A diamond team might be invincible, but it doesn't conduct anything. It's an insulator. It's completely static.
Right. A graphite team might be messy. It might have internal friction and differing opinions. But those differing beliefs, those free electrons, are the conduits that allow new ideas to actually flow through the system.
It is a fascinating critique of the text's own internal logic. The author might be severely discounting the flexibility and dynamic energy of a graphite-like organization.
Yeah, a completely unified, rigid team can't always adapt to sudden environmental changes.
In fact, just like a literal diamond, for all its immense hardness, a perfectly rigid team can actually be shattered into pieces if you strike it at the exact right angle along its cleavage plane.
That is a great point. Hardness doesn't equal resilience?
Precisely. But this exploration of management theory is still only the halfway point of the essay.
Right. It gets deeper.
The text pushes the carbine metaphor one step further, leaving the physical, observable world behind entirely.
Okay, I was with him on the corporate teamwork analogy. It's a really solid thought experiment, but the text then transitions into literally changing a human soul into an immortal Buddha.
It is quite the pivot.
How does he possibly justify making that kind of leap using the chemistry of carbon?
Well, we are entering the realm of spiritual alchemy now. We are moving from interpersonal team dynamics to the ultimate metaphysical claim of the essay. This is the third enlightenment.
Okay, lay it on me.
The author argues that if structure can change a lifeless rock, and structure can change a corporate management team, then structure can fundamentally alter the nature of a living consciousness.
So the mind itself is a structure.
Yes. And to explain this, the author introduces a concept called a life's antimatter structure.
Okay, I need you to pause right there and explain that, because antimatter structure sounds like something out of a science fiction novel.
It really does.
Is the text talking about literal physics here, like particle accelerators and antimatter? Or is this just another metaphor?
It functions entirely as a metaphysical metaphor for the unseen mind. Think of it this way. Your physical body is made of matter, arranged in specific ways.
Right.
The author posits that your consciousness, your soul, or your internal belief system is your antimatter structure. It is the unseen architecture of who you are.
The unseen architecture, okay.
And the hypothesis is this. Just as physical carbon atoms can rearrange to form totally different materials, the fundamental thoughts and beliefs of a life form can be rearranged to alter its state of being in the universe.
So we can rearrange our minds like carbon atoms.
Exactly. The text explicitly equates normal, everyday human beings to graphite. We are soft, unorganized, full of internal friction, and sliding all over the place.
Sounds about right.
But it equates immortals, or Buddhas, to diamonds.
Okay, so the text actually lays out a strict mechanism for how this evolution supposedly works. It claims that if a person's consciousness is disordered and chaotic, if their mind is like the loose, sliding layers of graphite, they evolve downward.
They literally devolve into lower forms of life.
But if a person's consciousness becomes highly ordered, rigidly structured, and perfectly aligned like the sp3 hybridization of a diamond, they evolve upward.
They transform into higher life forms. They become immortals.
It is an incredible philosophical escalation.
It really is. And the author gets highly personal at the very conclusion of the essay. Shofeng claims to have personally obtained the exact literal secret of this specific evolution.
Like a cheat code for immortality.
Basically, the text boldly asserts that if a person strictly follows the author's guided route for cultivation and practice, they will inevitably become an immortal or a Buddha, successfully reaching what the text calls a high-level space of life.
It's a massive, sweeping claim. I mean, we went from the boiling point of an atomic crystal to a literal step-by-step roadmap for achieving immortality.
Quite the journey.
And as we said at the top of the deep dive, we aren't here to validate or debunk the author's specific religious or spiritual route. We are just exploring the logic.
Of course.
But the conceptual framework they are using to justify that route is genuinely fascinating.
This raises an important question. Regardless of where you happen to stand on the author's specific spiritual or religious claims.
What's that?
The underlying philosophical prompt here is that achieving a higher state of being, whether you define that as spiritual enlightenment, peak professional performance, or just deep personal peace, isn't about acquiring new material.
Oh, that's profound.
It's not about becoming something entirely alien to yourself. It is simply about reorganizing the consciousness you already possess. The carbon is already there inside you.
It has always been there.
It has. It is just a matter of how you choose to link it together.
You don't need to go out and buy diamond ingredients. You don't need to find some magical new substance. You just have to figure out how to arrange your internal graphite. It's such an empowering idea, even when you completely strip away the esoteric context. It reframes personal growth. It changes it from an exhausting act of constant acquisition into an intentional act of internal architecture.
It shifts the internal monologue from asking, what am I missing, to asking, how is my current mindset arranged?
Am I scattered or am I locked in?
Right. Is my attention scattered, sliding around like loose layers of cards every time life pushes me? Or is my focus locked in, mutually supporting every other aspect of my life in a strong, stable grid?
It has been an absolute roller coaster of an analysis.
It certainly has.
I mean, we started by looking at a transition-type crystal with a density of 2.25 grams per cubic centimeter. We explored the deep science of CP2 and Sp3 hybridization.
The literal building
Uh,
blocks.
Then we used that exact same science to critique modern team management, examining both the dangers and the hidden conductive benefits of free electron employees who think differently than the group.
The nonconformists.
And finally, we followed the author's logic all the way to a grand metaphysical claim about reordering the antimatter structure of our consciousness to achieve literal immortality.
It really highlights how deeply interconnected human thought can be. It shows how a simple, rigorous observation of the natural world can bloom into a comprehensive, sprawling theory of life, society, and the universe.
It's amazing.
But before we wrap up, there's one final, unstated reality about the physical science of carbon that I think puts a fascinating twist on the author's ultimate claim.
Oh, I love a good twist. What did the text leave out?
Well, the author establishes very clearly that our highest potential, our immortal or enlightened state, is the diamond. And our messy, flawed human state is graphite.
Right.
But if you look back at the actual science in the very first paragraph of the text, how do you actually turn graphite into a diamond artificially? What does it physically require?
Oh, wow. The text said it requires high heat, extreme pressure, and a catalyst.
Right. Diamond is the hardest material on Earth, yes. But to forge it from graphite requires immense crushing pressure and staggering, almost incomprehensible heat.
Oh, I see where you're going with this.
So, if we accept the author's metaphor, that humans are graphite and our highest, most ordered state is a diamond, does that mean the only way to actually reach our ultimate potential is by enduring the most extreme, crushing pressures of life?
That completely flips the script. Can we become diamonds peacefully through quiet meditation, or does the architecture of greatness inherently require us to pass through the fire?
It asks us to consider the cost of that rigidity. If the goal is to become an unbreakable diamond, we have to accept that the process of getting there might be agonizing.
It might hurt. A lot.
Exactly. And it brings us back to our earlier debate about the free electrons. Is being a diamond actually the ultimate goal for everyone? Or is there a profound beauty and utility in remaining graphite?
In staying soft.
Yes. In retaining our softness, our dynamic energy, and our ability to conduct the spark of life, even if it means we are a little bit messy and prone to friction.
That is going to sit with me for a long time. Are we actively seeking the pressure to become unbreakable? Or are we just trying to survive the heat and keep our spark alive?
It's a big question.
It really is. Thank you so much for joining us on this deep dive. I hope you, the listener, take a moment today to look at the structures in your own life, your teams, your habits, your internal beliefs.
Look for the graphite and the diamonds.
Exactly. Ask yourself where you are sliding around like graphite and where you are locked in like a diamond. Keep questioning the architecture of your life, keep rearranging the pieces, and we'll see you next time.